everyone, welcome to the video on valence electrons. So first of all, what are valence electrons? Okay, valence electrons are the outermost electrons around the nucleus, and the chemical properties and how a element reacts depends on these valence outer shell electrons. Okay, we say that they're in the valence shell, the outermost shell. So in previous videos we discussed how we have our nucleus and then we have shells that are around it. Okay, so the electrons in the outermost shell of whatever the atom is, okay, those are the valence electrons. Okay, and these are the most chemically important. So you'll hear chemists and people say that, because the inner shell electrons are very low energy and they don't react. Okay, and so these outer shell electrons, these valence shell electrons, do react, and they will bump into other atoms and exchange electrons, or they'll share electrons. So these outer shell are most accessible. So these are accessible electrons to react. Okay, and so the chemical properties of elements depend on these. Okay, so if you look at the electron configuration for beryllium, so hopefully at this point you know how to come up with configurations. You would get 1s2, 2s2. So remember, this number here corresponds to the energy level. So the highest energy level for beryllium would be 2. Okay, and so if you look at how many electrons are in that energy level, you have 2. So the number of valence electrons for beryllium is 2. Okay, so you find the highest energy level, because that's the outermost shell, and then look at how many electrons are in it. Now this one often confuses students, and I'll get an answer. I'll get students to answer. I'll say, how many valence electrons does chlorine have? And I'll get an answer of 5. Okay, that is incorrect. All right, look at the configuration. It's 1s2, 2s2, 2p6, 3s2, 3p5. Okay, you have a 3 and a 3 here. Okay, so in the third energy level, you have an s orbital and of course 3p orbitals. Okay, so your outermost energy level is the third. So if you think about this, 1, 2, 3. So there's your outermost energy level, but you have 2 s electrons in it and you have 5p. Okay, so you have a total of 7 valence electrons, because those are the outermost. Those are going to be here in the third energy level. These would be in the second energy level. Okay, and so you have 5 in the outermost energy level. Excuse me, you have 7 in the outermost energy level. You have 5 in the P and 2 in the S. So you have 7 total. All right. Elements in the same group have similar electron configurations. So you may have already seen this trend. Okay. The elements in the same group have the same number of valence electrons. So that is why elements in the same group, okay, often have very similar chemical properties. Okay, if they're in the same group, they have the same number of valence electrons. Okay, and I'm going to show this on the periodic table here in a second. Okay, so if you look at group numbers 1A through 8A, remember these are your representative elements. Okay, the group number is equal to the number of valence electrons for your main group elements. Okay, your exception is helium. Okay, it has 2 valence electrons, so it's not in group 2. Okay, all right, that's because it's full when it has a full s orbital. All right, so let's look at this. Look at your group number. Here's your representative 1A, 2A, and here's your 3A through 8A. If the element is in group 1, here's your group, the whole vertical column there, then it has 1 valence electron. So this should match up when you look at the configuration, just like we did for those previous two problems for beryllium and one other one, okay, it should match up to what you write out, okay? And so if it's in group 2, these all have 2 valence electrons. If you're in group 3, 3 valence electrons. In group 4, 4 valence. 5, 5 valence, and so on. When you get to 8, these are noble gases. They have a full shell, so they have 8 valence electrons. Okay, except for helium, of course. It only needs 2 to be full. Okay, so the group number is equal to the number of valence electrons for any of the atoms in that group, and that is why they are so chemically similar, because they have the same number of valence electrons, so they're going to want to react the same. Alright, so this relates it. So it's great practice if you want to go back and write out all the configurations for all the elements, but what you're wanting to look at is the outer shell. So here, for instance, boron, okay, it goes out to the 2s and it has 1 2p. Okay, you can't forget about those 2s electrons, so it has 3 valence electrons. It's in group 3. So when you look at your configuration, it should match up with our rule or our little trick that we can use the group numbers to determine valence electrons. Okay, let's pick another one here. So let's pick sulfur. Okay, if I wrote out the configuration for it, the ending would be 3s2, 3p4. The 3 stands for the energy level, third energy level away from the nucleus, and it has 6 valence, 4, 2, 6 valence, and it is in group 6 on the periodic table. So all of those should match up. Sodium has 1 s electron in the third energy level. It's in group 1. Okay, so when you write out these configurations, look at the ending and be sure you don't leave off any of your s orbitals, okay, and add up your valence, and it should match your group number. We can also draw electron dot symbols that represent our valence electrons, and so we only need to show valence electrons because these are the only electrons that are going to be chemically important to us. And so what you do is you write out the element symbol first. So I'm going to pick this carbon one here. Okay, and that just stands for all the other inner shell electrons. So you just write the symbol for that. And then you go look at your periodic table or your configuration, and you see that carbon is in group 4. So that means it has 4 valence electrons. And we're going to draw them. That's an electron. And we're going to place them as single dots on 4 sides of that element symbol. Okay, you're going to place them singly into those 4 slots or 4 sides first, and then double them up if you have to. Okay, so something like oxygen has 6 valence electrons. So 1, 2, 3, 4. Now I have to pair them. Okay, and this will be important later when we're trying to draw what's called Lewis structures, and that's why we do this in this format. Okay, so you only look at the valence electrons and then you place them around. So for chlorine, it has 7. So 1, 2, 3, 4, 5, 6, 7. So it just has that 1 electron that's not paired. So guess what? It wants to bond in a way that it gains 1 electron, okay, to make it stable. Because if you look at a noble gas, okay, so if you look at something like neon, it has 8 valence electrons. So if you draw all the way in, 2, 4, 6, 8, it's full. It has a full, what we call an octet, or has a full, all of its orbitals are full. If you had something like magnesium, it's in group 2, so it has 2 valence electrons. So we would draw 1 here and 1 here. Okay, I want you to notice it's not wrong if you go the other way, or if you go, so like this is the same as this, the same as that. Okay, you can kind of mismatch where you put things. Okay, the whole point though is that you singly fill them first and then double them up. Okay, so that is the same as if you did this. Okay, but no matter what, for chlorine here, you have 3 pairs, and then you have one side that just has a single electron. Okay, so look at your periodic table, and I've got a couple practice questions. Which element has 4 valence electrons and is in the second period of the periodic table? Okay, and then we're going to draw the electron symbol for nitrogen and neon. Okay, so if you remember the question, it has 4 valence electrons, so that means it has to be in group 4, and it's in the second period. Okay, I chose this one because students often accidentally forget about your first period, right? Okay, that's this one right here that just has hydrogen and helium in it. Your second period, so here's my second period. It said it was in the second period, and it was in the fourth, had 4 valence electrons, so it's in group 4. So the answer would be carbon. Alright, we now want to draw a electron dot symbol for nitrogen. Okay, so I go find nitrogen. It's in group 5, so that means it has 5 valence electrons. Okay, so I draw my symbol, and then I do 1, 2, 3, 4. I put an electron on all 4 sides, and then I have to pair one up. Okay, which one you pair up doesn't matter. It's the same thing. Okay, and so there's my 5 valence electrons shown in an electron dot symbol. Neon is a noble gas, so all of its valence shell, or all of its orbitals, are full. So it's in group 8. So we would draw neon 1, 2, 3, 4, 5, 6, 7, 8. Okay, so they're all paired up. The little dots there are my electrons, and electron dot symbols represent valence electrons, the outermost electrons in the outermost energy level of the atom that you are looking at, and they're the most chemically important. Alright, I hope this helps with valence electrons. Thank you.